Alright, we're going to do the proof of VF equals VI plus AT. Okay, well, first thing we'll do is we'll start off with an assumption. We're going to make the assumption that slope equals acceleration on a DT graph. Sorry, on a VT graph. And we'll also draw ourselves a graph. So let's give ourselves some, well, what are we going to do here? We'll go from VI. We'll make it really simple. We'll go VI equals 0, and we'll show constant acceleration. So the object is going to have an initial velocity here. Going to go all the way over here to the final velocity. And really all we're trying to do is show that the slope is going to end up being acceleration. So it doesn't matter if we started at VI 0 or if we started with an actual VI and came up this way. It doesn't really matter. So what I will do is, because it's a straight line, I can choose any 2 points I like. I'm going to choose these 2 points there. And this is going to be my 1 point, that is going to be my 2 point, and you'll notice that they map across to here. That's going to be V1, and this one's going to map across to here. I'm going to call that one V2. This will map down to there. That will be time 1. This will map down to time 2. Now what I want to do is I want to go back to my slope. Dig deep. Remember, slope is equal to rise over run. We remember that, which is going to be equal to change in y over change in x, which is going to end up being equal to y2 minus y1 over x2 minus x1. And in this case, it's going to end up being equal to this 2 minus that 1. So my y's are my velocity axis here. So I'm going to go v2 minus v1, and t2 minus t1 is my x's. Going to make my, and that's equal to acceleration. Okay. I'm going to make another assumption here about t2 minus t1. I'm going to go over here, and I'm just going to go, well, look, if I'm subtracting 2 time frames, no matter what they are, I'm just going to refer to them in general as my time frame t. Okay? So that's what I'm going to do. So that's like an assumption that kinda is okay, but if we wanted to go t2 minus t1, it's just going to make the equation just slightly more complicated, and I don't like that. So I'm going to rearrange this thing here. I'm going to go a is equal to v2 minus v1, and I've just changed this to say t, and I don't like v2 and v1. I think I'm going to say, well, if it's a second velocity, let's just call it final velocity. And if it's my first velocity, let's just call it my initial velocity. There's my time frame. I'm going to rearrange this entire thing to VF equals VI plus AT. There you go.